Calculate the area under the graph of ln x over x. Sorry. It's ln x squared all over x. Just the ln gets squared. From x equals 1 to x equals e. So let's look at the solution then. Okay, so first of all, you have to understand that area under a graph is an integral, right? So the first kind of basic conceptual step here is understanding that you need to calculate an integral. So we need to calculate the integral. So we're going to integrate this function from 1 to e, right? So it's very important you understand that basic concept of integrals. All right, now let's talk about u substitution. So forget for the moment that we have these numbers 1 and e, right? If I just asked you, what is the antiderivative of this function, what would you choose to be your u function, right? And again, how do you choose u? U should be a function whose derivative is sitting outside. So you said ln of x. So is the derivative of ln of x sitting outside? The derivative of ln of x is 1 over x, right? And we do have that. We have a multiplicative factor of 1 over x. Okay, so good. So that is a good choice for you. So now let's make our translation table. Okay, so as normal, we start out with our choice, u equals ln of x. We compute our derivative. And then we algebraically solve for dx. So I get dx equals x times du. All right, now that would be the end of the story, right? That would be the end of the story if I didn't have these pesky limits of integration. But now, because I also have to change those limits of integration, my translation table gets a little expansion. I also now have to think about what are the new limits of integration. So the first limit of integration is x equals 1, and the second limit of integration is x equals e. I have to come up with what do these correspond to in terms of u. Remember, everything has to be changed from x to u. In disguise, this is really saying x equals 1, x equals e. So I need to change this. When I make this a new integral, I need to change that to u equals something, u equals something. So how can I actually do that? Well, it's actually very simple. I just use my translation table, the u equals ln of x, right? U equals 0. If x equals 1, u equals ln of 1, which is just 0. If x equals e, u equals ln of e, which is just 1. And again, if you're asking, where did I get these numbers, right? This is coming from the first line of my translation table, right? That first line tells you the relationship between x and u. Okay, so let me just erase these markings here. So now let's do the translation. So the translation now has 3 parts. So as usual, I have the u, I have the dx, I have the stuff I'm not really sure how to translate quite just yet, but now I also have these limits of integration. Same. Right, so let's put everything in here. So the ln of x just becomes u, right? That's u squared. The x in the denominator, I'm really not sure what to do with quite just yet. The dx, according to my translation table, is x times du. And then my two limits of integration, the 1 and the e, correspond to 0 and 1. Weird that I thought that was a polygon. That's weird. Okay. So if I just rewrite this without all the colors kind of in the way, this looks like the integral from 0 to 1 of u squared over x times x du. Now, you cannot compute the integral until all of the old variable is gone, right? You need only one variable. So it's very important that those x's actually do cancel out. And I'm left with the integral from 0 to 1 of u squared du. All right. Now, once you do your translation table, all of this is now gone, right? I don't care about any of this, right? The old variable x, I no longer care about. Why? Because the only thing I'm actually doing is I have now rewritten the original integral in terms of this new integral, and all I need is to compute that. Now, how am I going to compute this integral? The integral of u squared from 0 to 1. Find the antiderivative of u squared and then apply fundamental theorem of calculus. That's right. Fundamental theorem of calculus tells me I just need to find any antiderivative of that, then plug in the two numbers. So an antiderivative of this is 1/3 u cubed, and I substitute 0 and 1. So I get 1/3 times 1 cubed minus 1/3 times 0 cubed. So my final answer is 1/3. Notice I never went back to x, right? Because I don't have to. The final answer should be a number. It's not not in terms of x. Notice it's also very common for students to get to this part and then go back to x, then start rewriting. Oh, this is 1/3 ln x cubed. First of all, the numbers would be wrong. And even if you did go back to the original numbers, even if you then put in 1 and e instead, why? Why go back to x? The whole point of using the variable u is to make the integral easier, right? There's no point to going back to the variable x. I used to say that this was actually some good life advice. Actually make a note of that here, right? No more x, only u. And I do think that's some good life advice too. So if you just say that out loud, you'll realize what I mean. Yeah, I know.